Okay, so we're going to keep going with curve sketching, but today we're going to look at rational functions. Do you remember these guys? They're the ones that look, like this, or like this, 3x plus minus 5. So these are rational functions. They're like fractions on steroids, and we're going to look at how to sketch those using our first and second derivatives. So let's start with one that's actually behaves itself a little bit. So x squared over x minus 2. So what we know so far about curve sketching is that our first derivative helps us with max and mins, and our second derivative helps us with concavity, right? So we're going to put all of that to use. Now, our first derivative helps us with what? What's its job? Its job is to give us coordinates, and its job is to give us x and y intercepts. So if we look at this, our goal is to sketch a curve. Okay, this is our goal over here, sketch a curve. To do that, we're going to use everything in our arsenal. We're going to use intercepts, we're going to find max and mins, we're going to find concavity, and we're going to go from there. So let's start with what we know. Let's start with x and y intercepts. Now, x-intercepts occur when y is 0. So we're going to make our 0, and then we're going to have x squared over x minus 2. And we're good at algebra, so we're going to understand that we can just multiply both sides times x minus 2. And that would be our first step. And then, of course, these cancel, and then 0 times x minus 2 is 0. So 0 equals x squared. So what does that mean? Take the square root. Our x-intercept is at 0, 0. Okay, so here's our x-intercept. So that's useful information. Now, in the interest of space, I'm going to erase that. Now let's find our y-intercept. Our y-intercept happens when x is 0. So 0 squared over 0 minus 2 is 0 over negative 2, which is 0. So our y-intercept, shocking, is at 0, 0. But that was worth going through the process because that won't always happen, obviously. So just making sure we know how to find a x and y-intercept. If you don't, I failed at my job, I think. Okay, so 2 important pieces of information. So I'm going to go over here and I'm going to plot that point. Okay, let's look for max and mins. So our max and min is when our derivative equals 0. So our derivative equals 0, and we're going to need to use quotient rule. So I'm going to, in the interest of time, why don't you hit pause, you figure out what the derivative is, and come back. And then hopefully you'll have it. I'll wait. Okay, I'm hoping for your first derivative, you got x squared minus 4x over x minus 2 squared. Now, if we set this equal to 0 and solve, let's see what we get. So I'm going to make this equal to 0. Move this up here. So I still have x squared minus 4x equals 0. Okay, so I'm going to factor out an x, and I'm going to have x minus 4 equals 0. So now I can split that, and I've got x equals 0, and x minus 4 equals 0, x equals 4. So here are my 2 max and mins, okay? So I've got a max at 4 something, and at 0, well, we know 0, 0. Okay. Useful information again. Okay, so what we're going to do then, remember, this is max or min. So now we need to make ourselves a sign chart. So we're going to make our sign chart, and I'm going to put my 0 here and my 4, and then I'm going to pick test points. So let's pick -1, 1, and 5. How's that sound? Okay, so let's look and see what happens. So if we take our -1 and we put it in here, we have 1 plus 4 is 4, -1 minus 2 is -3 squared, 9. So that's positive. So that's going to be increasing. So this is increasing, going up. And if I plug in my 1 test point, I'm going to have 1 minus 4 is -3 over 1 minus 2 is -1, 1, 3. What did I say here? 1 minus 4. So negative, I get a negative number, right? So this is negative. So this part's decreasing. And then my 5, if I plug in 5 here, I get 25 minus 20. So 5, 3 squared, so that's positive. Okay. So this is a positive. So there's my intervals of increasing and decreasing. So that's important. Now let's come over here, and I'm going to erase this mess, and let's tackle our second derivative. So go ahead, hit pause, find your second derivative if you would like. Okay, so our second derivative is, let's see, what's it going to be? Okay, I believe some fancy footwork is going to lead you to 8 over x minus 2 cubed, but you had to do a decent little bit of multiplying to get there. Okay, set that equal to 0. That's going to tell us our inflection points, right? Our second derivative gives us inflection points. And so when we start to solve, if I move this up here, I get 8 equals 0. So what's happening there? So that's not going to work. And what that means is that there are none. There's no inflection points. Okay? Super important piece of information. No inflection points. Now, I'm hoping some of you are saying, but Goodboo, what about the asymptotes? Because what did we always know about rational functions? We knew they have asymptotes. Okay, so let's add another layer to the mess we've made. Where is the vertical asymptote in this rational function? Vertical asymptotes come from denominators. What number would make this undefined? 2. So we have a vertical asymptote at x equals 2 because it would be undefined, right? What about a horizontal asymptote? Would there be a horizontal asymptote here? The horizontal asymptote would be, remember you would look at this and you would say, you would look at your highest x's and you'd have x squared over x, simplify that to x. And as you take the limit to infinity, that means it's going to infinity, so you'd have an oblique asymptote. So there's not actually a horizontal asymptote. It's going to be one of those like diagonal ones. So what does that mean for our graph? So this vertical asymptote on our graph means that we have something undefined right here at 2. And then we also know we have a maximum happening somewhere around 4, a minimum on x equals 4. So we're going to have a low point there. We're going to have a high point, and coming in, let's look at this. Coming into 0, we need to go up and turn back around at 0. So our graph is going to have to do something like this, right? It needs to come in, be increasing to 0, and then decrease. And it needs to pass through 0, 0 because it's the intercept. On the other side of 4, it needs to be increasing. So it's decreasing until 4. So from 0 to 4, it's decreasing. So that means on the other side of this 2, it has to keep decreasing until we get to 4. So if this is 2 and this is 4, it has to be decreasing as it comes into 4, and then it has to turn around and increase as it leaves 4. Does that make sense? And the concavity can't change, right? So this is concave down, this is concave up, and it can't change because there's no inflection points. Does that make sense? So we've got our x-intercept and our y-intercept, our undefined vertical asymptote, our max and min, right? This is like the highest turnaround point. And remember, max and min just shows that you go from increasing to decreasing. Here, we're going from decreasing to increasing. And remember, we don't really know, I didn't find the coordinate on this, so this whole curve could be higher or lower. All I know right now is that it has to stay on the right side of this 2. Okay, let's try uno más. Oops. Okay, so let's do one that maybe follows the rules a little bit better. Probably not much, but sure. Let's see what we got. Okay, so let's say this time we have f of x equals x minus 4 over x minus 2. Let's do this a little bit differently. Let's start this one with asymptotes. So let's start by finding vertical asymptotes, horizontal asymptotes. Then we'll look for intercepts and y-intercepts. And then we'll go into our first derivative, our second derivative. So then we'll look for max and mins, and then we'll look for inflection points, okay? So all of these things that I just listed are considered critical points. So if you're ever asked to find critical points, these are all what we call critical, okay? So these are our critical points. Okay, so right off the bat, we can look at this. Where's my vertical asymptote? It's at 2, okay? Again, it's at 2 because that would give me an undefined denominator. Where is my horizontal asymptote? Well, remember, we ignore the numbers. We look only at our highest variable. X divided by x simplified is 1. So I have a horizontal asymptote at, not x, sorry, y equals 1. Okay, x-intercepts. X-intercepts come from your original function. It's when y equals 0. So x-intercepts are when you have 0 equals x minus 4 over x minus 2. Move that up here. 0 equals x minus 4. 4 equals x. Here's my x-intercept. 4, 0. Okay? Y-intercept. Y-intercept. Also from your original function, when y equals 0 minus 4 over 0 minus 2, which is negative 4 over negative 2, which is in fact positive 2. So my y-intercept is at 2, 0. Okay? Keep moving. Hit pause while I find the eraser. Good grief. Okay. You're going to need to use quotient rule to find the first derivative. So we need the first derivative and the second derivative if we're going to find our max, min, and inflection point. So hit pause. You go figure that out. Let me know when you're done. Okay, got it. So our first derivative should be 2 over x minus 2 squared. Everybody get that? Okay, so if we set that equal to 0, we get 2 over x minus 2 squared. Remember, I'm looking for max and mins right now. If I move this up here, I get 0 equals 2. I've lost all my variables. what could this mean? This means that there are none. It doesn't have a maximum. So, okay, so there are none. Okay, let's go to inflection points. Let's look at our inflection points. Our inflection points are going to come from our second derivative. So find our second derivative. I hope you already found that. Our second derivative is -4 over, let me think, x minus 2 cubed. I hope is what you found. Okay, so x minus 2 cubed, we're going to set that equal to 0, and the same thing is going to happen to us. We're going to try and move this up, and we're going to get 0 equals -4, and obviously that doesn't work. So that means there are also no inflection points. Okay, now you're like, well, then how am I supposed to know increasing or decreasing? Well, here's your new piece of information. Because I told you that all of these are critical points, you don't have a critical point to deal with here, but this vertical asymptote can also lead you to a sign chart. So we're going to take this 2, and we're going to do a sign chart for increasing and decreasing with that, because it's also a critical point. So let's pick some test points. So we can pick 1 and 3. And what derivative tells us about increasing and decreasing? Our first derivative. So we're going to use our first derivative to tell us about that. So I'm going to plug this 1 into my first derivative. So I'm going to have 1 minus 2 is -1, squared is 1. 2 over 1 is positive. So this is increasing, going into my vertical asymptote. I'm going to plug this 3 in to my first derivative. 3 minus 2 is 1, 1 squared, 2 over 1, so increasing as well. So I'm going to get increasing on both sides. I don't know that we've encountered that. I've told you it was possible, but I don't know that you were listening. Okay, same deal. Because we couldn't identify an inflection point, we still have to know if it's open up or open down. Like, we can still do that. So again, we're going to keep using this 2. So now we're going to find out concavity, and we're going to use our double prime for that, right? So I'm going to keep using the same sign chart. I'm just going to switch what function I use. So I'm going to plug my 1 into my second derivative. So 1 minus 2 is -1. -1 cubed is -1. -4 over -1 is positive. So this is going to be concave up, right? Concave up. Now I'm going to take my 3 and I'm going to plug that in here. So 3 minus 2 is 1. 1 cubed is 1. -4 over 1 is -4. So this is concave down. Okay, so this is quite the conundrum. First of all, do you see how I'm using one sign chart for both? Useful. Also, I have increasing concave up and increasing concave down. So what is this bad boy going to look like on my graph? Man, this is about to be the best graph I've ever drawn in my whole entire life. Okay. Here's my graph. Oh my gosh, look how straight those lines are. Okay, here's my graph. I'm going to go ahead and I'm going to put in my vertical asymptote at 2. I'm going to make it yellow. Okay, so we can't cross this yellow line. Okay, I have an x-intercept at 4, so that's good. And I have a y-intercept at 2. Okay, so 2, I have an intercept, and 4, I have an intercept. So I have to cross through those. So let's start on this left side. So on this left side, all the way up to 2, I'm increasing and I'm concave up. And I don't know anything other than I'm going to go through this dude. Oh, what else do I have? I have horizontal asymptote. Geez, guys, you got to tell me these things. Okay, horizontal asymptote. Okay, so I'm increasing and I'm concave up. And I need to pass through this. Okay, is that increasing and concave up? Yes. Okay. On the right side of 2, I'm increasing and I'm concave down, and I need to pass through this 4. So increasing, concave down, pass through 4. And we're done. Okay, so how do we feel about this? Let's walk through this one more time. To be clear, our critical points are vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, max, mins, and inflection points. All critical. If you do not have a max and min or inflection point, your vertical asymptote can serve as a divider to test for concavity and increasing and decreasing. You can test on either side. You test for increasing and decreasing still with your first derivative. You test for concavity with your second derivative. You can have increasing followed by increasing, and look right here. These both are increasing even though they look very different, and it's their concavity that's making them look so different. So one strategy I tend to use is I just write at the very beginning, I take my original function, I find my first derivative, my second derivative. I know I'm going to need them, so I just go ahead and I find them really quick. I list all my critical points down the side, and then I just work through each function to find all of those points. I keep one sign chart that has my increasing and my concavity all in one, and then I throw it on a graph at the very end. So I hope that makes sense. I wish you the best of luck with this.